I'm very pleased to welcome Mark Reckase, a University Distinguished Professor Emeritus, Department of Counseling, Educational Psychology, and Special Education at Michigan State University, who will be talking to us on the changing significance of the ordinary item.
Well, first, I just want to thank Amy and Division 5 for inviting me. When I got the email and everything else inviting me, I thought it was one of these things like I get a phone call every once in a while if I'm not paying attention. They say, because you've stayed at a Hilton hotel in the past, we are going to give you a free trip to Florida. All you have to do is listen to somebody give you a pitch to sell you a condo for 2 hours. And, So it's the same deal here. I got a free trip, free vacation to central New Jersey, but I have to listen to these presentations all day. So it's, so anyway. The topic I've got here, the title actually comes from an interesting place. I don't know if the title really has anything to do with what I'm going to talk about. Yeah, I am going to talk about test items. But I was running across this issue about when we started using the term test item as opposed to test task or test or question. And I don't know the answer to that. And I started searching on Google. And for some reason or other, a book came up that was called, the title was The Significance of the Ordinary Button. Buttons as on jackets and things. And I said, well, that's interesting. I want to read this book, So, but I borrowed their title to talk about the ordinary test item. And I don't really know what the ordinary test item is. So, but we'll get into that a little bit as I get into this. One reason for doing this talk is I think the test items are really underappreciated. And that people ought to do an awful lot more about the quality of test items. Ultimately, I would love to have a publication that was a reviewed publication where people would publish the best of test items so they could serve as models for future test items. And because people learn how to do this, and then the tests are secure, or with stuff that shows up in sample, the test booklets are usually the worst of the test items because you don't want to use the good stuff. So it's kind of, you've got all kinds of problems here that go along with it. When I went through graduate school, I went through psychology, got a PhD in psychology, and I didn't really learn a lot about test items. I learned about how to analyze tests and how to analyze test items, do item analysis, but I didn't really learn about them until I got a job working at ACT, and I was in charge of putting the ACT test forms together. And I had a woman who was, had her title was called editorial manager, and she was the chief item editor for these. Her name was Renee Huntley. And she taught me about test items. We would literally sit down there and I'm putting test forms together because at those times we didn't do it by computer. We had cards, and then pink cards were math items, and blue cards were reading items, and green cards were science items. And we had all these things. We had a big table. We spread them all out. And we made forms. So and I'd look at these and I'd have the item statistics and all these things, and I'd find out about the test items. And I'd say, here's a test item. It didn't work. And she'd explain to me why it didn't work. And she was really, really good at it. And we had a number of people who were very, very good at it. So I was interested in how test items worked. But to get into this, I want to do a little thought experiment. I actually thought about having Amy do this, set this up for me. I want you to imagine we have a big bucket of sand, in front of us. And in this big bucket of sand, there's an object buried. I've always wanted to do this in class, too, to just have fun with it. And I'm going to give people a whole stack of metal rods, it's like, straightened out coat hangers, and say, okay, your job is to go over and figure out what is buried in this bucket by pushing down these rods into the sand to see what's there. And if you have this task, how would you decide where you're going to push the rods, and how many would you need to use to go over and figure out what this object is? Now, of course, if you think about this a little bit, you'd have to use a lot. Now, they actually have these things you can buy in novelty stores where you can get a lot of pins and you push it up against your face and you get a sort of an image of your face that's recorded in these pins being pushed out. So this is sort of the concept. But this is the way that I sort of think about test items. They are probes. You have these metal things. We have something that's unobservable, and we're trying to find out things about that unobservable thing, whatever it is, by using some kind of probes. Okay, so this is our challenge of psychological and educational measurement. Now, I say almost all cases, these things are not directly observed. There are a few things where you could observe everything. Like if you're doing single-digit positive number arithmetic, you could go over and do all of them. And you could observe directly whether somebody could, sum all these single-digit, pairs together to get things. But almost every other case, we can't. So what we're trying to do is to infer something about what it is we're interested in measuring from the results of these probes that we have. And this is the validity part that Mike was talking about earlier. We're trying to have this inference about this is what this means. But the task of designing what the probes are often, undervalued. That's at least my opinion of this. Now, we think that this is a unique problem to psychology and education. We're trying to see into somebody's head, and you can't get in there to see what's going on. But this is not true. I gave a talk about this a lot of years ago, and I talked about the fact, and Mike sort of commented on it a little bit. Back in the old days, we have what was called physics envy, that we wanted to make, educational and psychological measurement more like physics. We wanted nice equations that you could put together, and it's going to predict what's going to happen when, So we had this idea of physics envy. So the other parts of physics and sciences in general, they do actually have the same problem. I don't know if anybody recognizes what this is. You have to have old physics. This is what's called a cloud chamber, which is the way you go over and find out what happens when you shoot a particle at something and then see what bounces off when you shoot off the particle. And by analyzing this, you could figure out, the things that are squiggly are things that are charged particles, the things that are straight are things that are uncharged, and you get all kinds of information. So this is the way they used to do this. They don't do this way anymore, but it's probably in a museum somewhere. But it's the same problem. Do you really believe in this table that's in front of you that there are all these little atoms and quarks and protons and neutrons and everything else in there? You can't see them. You believe it's solid and there's all those spaces in between. That's the theory. So, this is the same problem that we have, except, in a different way. And here's another example. I copied this out of a science textbook, I think it's middle school. There's the Earth, and then there's supposed to be an inner core and an outer core and a mantle and all this kind of stuff. Do you know that stuff is there? I remember when I was maybe in high school, they were going to have this project where you're going to try and drill through the crust of the Earth to get down to see if it's really there. It's called the MOHO project. And, I don't know if they ever got there. they were, trying to do this. But they actually, it's the same issue. How do you decide what's on the inside of the Earth when you can't see it? And what they do is they do seismic things. They go over there and they set off explosions and then see how the sound waves that are created by the explosion bounces off of rock layers, and then they go over and create the rock layers. Originally, the way this was done is the first geological map, which was done of Great Britain, was a guy literally went down into every mine that there was and checked all the different layers of rocks in there to go over and say, well, the coal is down here, and put them all together, going through visiting all these mines and wells all over the country, and then put them together and made up a geological map. So now they don't do it this way, but this is the same issue. We're trying to go over and see things about something that's unobservable, and we're trying to infer what's there from the probes that we've got to go over and get that information. So this is a common scientific methodology. This is probing to go over and find out about things that we see. So now I look at these, it's pretty much the same kind of thing, and I think it's kind of fun to think about it this way, that we fire test items at somebody and then see what bounces off. See, and it's just like the cloud chamber. There are bubbles that kind of bounce off, and then we go over and analyze the bubbles. So it's kind of to see what we can infer about what's going on. Actually, you're now getting computerized, so the bubbles are only left on there for people to click on. It's not nearly as much fun. But the point is that test items need to be developed as carefully as all these scientific instruments, which are very expensive. And right now at Michigan State University, they're building a new accelerator. It's called the free ion bombardment system. It's called the FRIB. And it's this huge building that's cost, we never pay that much money for anything in psychometrics. These people in particle physics really got it going. It's kind of, but anyway, we're firing these things and you're finding out about what's going on with these things. So the geologists, they set off these explosions, An interesting thing when I was looking at this is, back in 1849, the way weather forecasting was done is there were 150 volunteers spread around the country, and every day, by telegraph, they would send a message to the Smithsonian that said what their local weather was like. And then the Smithsonian was trying to put together, the forecasts were not very good. These were not randomly distributed people. They were volunteers. So, so things have really changed. Okay, so in the early 1900s, people, because of physics envy, as I say, Galton was building these tests, his Galton tests, which were really kind of fun. I always liked the one that was called pressure causing pain. They'd push a metal thing into the back of your hand and see how much pressure there'd have to be before you said, ouch. This was supposed to be predictive of college performance at the University of Pennsylvania. It's kind of, I guess if you can deal with pain, then you can deal with college. Well, we got the Binet test for intelligence. We had, in education, Rice was developing educational tests in Kansas, which predominantly were about spelling to find out how to most efficiently go over and teach kids how to spell. And so we got all these tests that were being produced. Most of those wouldn't be what we would necessarily call test items. I don't know if you want to call one of the psychophysical tests that Galton was using as an item. It was some kind of a physical thing that you did. The Binet and things Rice was doing was closer. I have a whole bunch of stories I could tell, but since lunch is coming up, I won't tell them. But in honor of the old SAT, since I went over and found from 1915 analogies, verbal analogies, and I think everybody can probably get the first one right. Oyster is to shell as banana is to peel. Peel. Okay, you guys all get a point. But the next one I put up there on purpose because truth is to falsehood as straight line is to curve. I actually thought, the coded answers to get is either curved or crooked. But I personally would have put down broken, as a broken line, as opposed to, and I think this is a really bad analogy. But anyway, so this is a bad test item. But it was used in one of these tests that Reckase put together. This is part of the Army Alpha and Beta, tests that were being produced. Okay, so our current testing model, this large-scale testing model we have, if you get into the history of it, this is all the Army Alpha and Beta things go back to World War I. And the original goal of all this was to make military training more efficient. And what they were really trying to do is to find out if people had enough background knowledge and everything else to be trainable. The people who didn't, they were going to go over and be sent as foot soldiers. And the people who could do these things, then you could be in artillery or something else, and and that they'd be trainable for higher level kinds of occupations within the military. So they started, later on, they actually started using these tests for everything, for officer candidates, for all kinds of stuff, because they found out they actually worked pretty well. And then after World War I was over, then the people who had worked on this, Otis used these things to create the Otis Quick Scoring Intelligence Test. Then people had started doing educational testing. The Stanford Achievement Test kind of came out of this. And so all the people who had worked for the military on all this started applying and said, hey, this worked great in the military. We're going to apply it everywhere else. So the challenge, though, that we have is to produce sufficient quality probes, that's these test items, that are going to give us the information we need to accurately infer this unobservable information that we want. And this is ultimately the validity question. Now I'm going to give you, just for fun, here's a couple of test items. And I'm going to say, when were these items written? Anybody want to make a guess? Even a decade. No one wants to guess. Okay, I'll just tell you. 1950s. Okay. Actually, they were written in the 1920s. This comes out of a book by, I think it's Rook, it's R-U-C-H, that is, he was producing these tests to be used by the schools. The interesting thing about the first one, I was looking at the current SAT and ACT tests, and this first item over here, this math item, there's items that look very much like that right now on these current tests. The second one over there is a little bit, I don't know if the science is still right on that one, but I think it probably is. I think the answer is radiation. But the physicists in the group can tell me if if that's still a correct answer. But this was from that same time. This was a science item that was being used. Okay, here's some more items. When do you think were these items produced? Any guesses?
I think 1980.
1980. Well, these are on the current Michigan school test. And actually, they're on the 8th grade test. And I looked at these and I said, this is ridiculous. Actually, I was looking at that first item and I was looking at it. Basically, the first item, all you really have to do is notice that the x-axis is the same and look at the y-axis and see that it's 7 points apart. All the rest of this stuff is distraction. It's, but this is a result of this idea that you have to be putting items into context. Same thing's true on the second one over there. The main idea of that, I think the answer is oxygen, is that radiation will break apart water molecules, and that you'll get oxygen and hydrogen out of it. And but you have all this text that's around it. Now this is me personally, I think these are actually better items, but that's my own judgment. You may have a different judgment depending upon your view of education. Is that because of this need to go over and put things into realistic settings. There's actually a longer thing. There's another scientist who they're talking to each other and all this stuff to go over and get at all these things. So these are current kinds of differences in items. Now the real problem out of all this is, assuming we have good item development, the problem is that we have a relatively small number of probes to be used in order to go over and find out the information that we need to make the inferences we want. So in the ACT math test, when I was working on it, there's 60 multiple choice items. You get 60 binary digits out of this thing. And from that, you're trying to infer this information about the mathematical capability of a person who's going to go off to a college or university. Of course, open-ended items, you can get more points per item, but they take more time. And our big issue here is this time factor. Time is the limiting factor. How much time are schools, people, whatever, willing to sit down and take this test? And I've used this picture before, so some of you will know what this is all about. But the thing the reason I put this up is because I was at a NAEP meeting, and this was back in the early days of NAEP when Roy Truby was still around. And he always talked about NAEP as giving us a snapshot of what's going on in the country at this particular point in time in terms of education. And I got this thing in my head, the snapshot. So I said, well, okay, here's a snapshot. Here we've got 56 cells here. There's 7-point graded responses, that's 7 levels of gray that are in here. And this is a snapshot. This is a real picture, but can you tell what it is? This is your 56 pixels of shades of gray. And so to help you out a little bit, I went over and said, okay, we're going to get more. We're going to be like if it's a 20-point graded response item, so we can add color. Okay, so that's, now you're getting a lot more information. But what the picture really is that. This is my grandson. That's when he was 4 years old. He's 8 now, so he doesn't look like that at all. I had to ask his permission to put this up because he's very sensitive now about things on the internet and everything else. He tells his parents, you cannot post pictures on the internet without my permission. So it's kind of, so there's a changing world out there. So I had to get his permission. But look, this is what people want. This is the true snapshot, but this is actually what we're giving. This is, we're trying to make an inference about this from this kind of thing. So how do the other sciences deal with this problem? Well, we now have, for weather, we have many, many, many weather stations. We also have weather satellites. We have all kinds of stuff that's going on. We have huge computers that are running, wonderful models to go over. And you see in the news now that there's like, I don't know how many models there are because every time there's a hurricane, you see about 10 lines. So all these different models that have been produced. The particle physicists, they no longer use the bubble chamber. They go over and they take the place where the impacts are going on. They surround it with electronic detectors. And they're in real time collecting everything that's going on all the time. And then they also have large computers that are going to go over and do this. The geologists, too, have gone, first of all, they have seismographs everywhere. And so every time there's an earthquake, they get information. But they also have trucks that the oil industry uses, which are called thumpers, that have these things that bang the ground. You know, you go wherever you want, you see them on the side of the highway, and they go bum, 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 bum. And they're getting the echoes back from those things to go over and get more information about the location of all these things. So the technology has increased, and then they get the computers to go over and process all this. So where are we going with our kind of areas? So our current model is inadequate. And that's really because people want this detailed picture. That's why everybody wants subscores all the time when you say you can't give them, because you know, there's too much, there's not enough information, or it's redundant information. So what the trend has been is for test items. First is to collect more detailed information for every test item. So there's a lot of stuff out there on getting response time or response latency. And people are trying to build this into the model. They're trying to get more information from each administration of the traditional test item. Second thing is they're trying to go over and collect process data. I was actually surprised a number of years ago. I was at a NAEP meeting, and they were doing the NAEP writing assessment, which was just moved on to computer. And I asked the people who were running it, I said, are you collecting anything about, you know, the process? Does a person make corrections? Do they go back and reread? Do they move things around? Do they cut and paste? Do they use a spell checker? And I said, no. And I said, well, why not? He said, well, it'll take up too much storage. Like, come on, I said, storage is cheap. You know, you can, well, then we'd have to process it. You know, we'd have to figure out how to process it. Well, okay, so, but that's the thing. So people are now starting to collect this process data, and they're trying to figure out how to process it. Now, an interesting little side story, I'll make it real short. Years ago, when I first started the research, I was over at a meeting, and it happened to be in Memphis, Tennessee, but a guy from the Air Force came and said, you know, we've got these flight simulators where we train people, and the flight simulator, when it's doing a problem, we get 1 million points of data from every simulation. And we usually look at it and say, did the person land the plane correctly or not? You know, so it's kind of, but they've got this 1 million pieces of information, but they didn't know how to analyze it. And so they said, would you guys figure out how to analyze this for us so we can get more information out of our flight simulation? Now, I have no idea whether that's been done yet. Maybe somebody here has worked on that as a project, but this is, you know, same issue. We also can start producing big items. This is what I call simulations, and hoping that we can get multiple pieces of information out of them that are going to be at this. Or we collect products over longer periods of time. This is in the first presentation today. When you start collecting everything that's going on in a classroom over a period of time, you can get a lot of information, but you're going to have to figure out what to do with it. Now, when I worked at ACT, I actually had a great project that I worked on, which had to do with portfolio assessment. And we worked on this for about 3 or 4 years. We were going to get structured portfolios of the students' work from their regular academic work. So no test, you just put in a folder what it is you've done over the year, and then we're going to score this formally and give a score based on your collected work. And the difference between what Randy was talking about and this, we would ask people, students, to put the stuff in the folder, then at the end to do reflection and pick out the stuff they wanted to show. So they collect everything, but then pick out the pieces according to an outline and say, this is what we want to show. This actually worked really well. There were 2 problems. We never turned this into a viable product. 2 problems. One is we discovered in order to have good products in your folder, you have to have good instruction. And some teachers who were thought to be really wonderful teachers didn't have good assignments. And so the things going into kids' folders were not very good, and they didn't score very high. And then, but the people at the school would say, no, this is our best teacher. You know, everybody loves him. It's wonderful, you know, kind of. And you'd say, well, but the assignments aren't very good. That's why the kids love him. They don't have to work very hard. So it's kind of, you know, so it never turned, and the universities didn't really want to look at all this stuff. So it never turned into a viable product. Okay, I only have 22 slides here, and I'm down to what, that's 19. So we're going to be, you know, it's not going to take too long. So in preparing for this, 5 minutes, no problem. In preparing for this, I went over and I keep a database of articles that I update almost every day, you know, as I'm finding things in journals and stuff. And I was looking, there's 3,870 articles in there right now. So I went and did a search on this to say how many are actually on item design and development. And there were 10 out of these 3,700. Now there were 28 that were related to computerized item generation. So people want to be able to generate items by computer, but there isn't a lot of work on how to design them. Instead, they do what we would want to say is cloning. Going to say, here's a good item. Can we make 50 more of those, that are like this item? So where most of this is going, what we want to do is be able to predict the item statistics, so we don't have to do item calibration. We can just say this item was cloned from this item. We know what that one was, so we're going to say it's going to work the way the other one did. So we're trying to get rid of this expensive part of tryout for these items. Now, actually, I did this at ACT with a group, and we created item clones. And we actually did a formal study, which is published, which is we made 10 forms of cloned items. So there's a 20-item form. Each item on that form was a cloned version of another one, and we made 10 forms of those. And then we administered them to randomly equivalent groups. And the hope was that if we looked at item 1, the difficulty of that item would be the same across all 10 forms, and item 2, the same thing. Well, what we found is that was true in about 8 or 9 cases, but usually there was one that worked differently, and had a slightly different difficulty. And so you have to think about, well, is that sufficient certainty to go on and use this kind of process and believe that this item has that particular set of characteristics? So we looked at difficulty, discrimination, all kinds of stuff. And so at the end of it, we said, well, we're not feeling real comfortable that this, because of that one, and you couldn't figure out why, because we didn't understand enough about the way the items work to know why this one didn't work like all the other 8 or 9 did. So this was a particular problem. Okay, so other directions that are in that literature. They want to predict item parameters from item features. There's a lot of reports from ETS about this. People have done a lot of work where they kind of code features of items, and then they try and predict the item characteristics from them. I don't know what happened with that. If people are still doing that, or if it works, and you don't have to calibrate anything anymore. No, okay. Item generation, there is some work that's, I think, really good, where they're starting to try and do item generation, but this item generation they're not cloning, they're trying to go over and create items from a certain kind of characteristics, and it requires having some understanding about how the item works in order to do this. Now, there's only maybe 1 or 2 articles like that, but there are a few where people going over into cognitive science to go over and try and understand the mental processes. And the other side of this is, do all people use the same mental process on the same item? And this relates to what Kurt was talking about when you get into, going in adaptations across countries. I've got a whole bunch of stories about that. Game-based assessments are cool because the people are motivated by them. And then you can get, in theory, a lot of information out of them. And then the question is, can you pull out all that information and make it useful? Now, I did see just recently, and one about training item writers. This has to do with alignment studies, that states are all concerned about alignment studies, and when they have an independent group come in and look at items and say, what level of challenge do these items present, people rate these things, and if they don't have sufficient level of challenge to match their test specs, then the federal government gets upset, and they don't get alignment and all this. So they're trying to figure out how to train item writers to make sure that the items they produce will be rated high in level of challenge when the alignment studies are done. And so they're trying, again, to figure out what makes an item work. So this is what's in the current literature. Now, the conclusions, for me, all this has potential, great potential, but complex computer items take more time typically, and it's a question of, can you get enough information out of those things, enough data points, so to go over and justify the amount of time that's going into it. This goes back to those items I showed you as examples, that math item with all that text and the science item with all that text. Those take longer because somebody has to read those. And when I worked at ACT, we had to fight all the time to keep the correlation between the reading test and the science test down to an acceptable level. Because in order to give the science stuff, you had to have enough words so people could understand what it was about. And then, unless you do it really simply, you can't. Okay, this is my last slide, I think. So anyway, what we need to do is be able to figure out how to get more information out of this about the target construct. And some of these more complex items are used because they're good models for teaching. Me personally, I like the idea of portfolios as a way of collecting this, but I think it's got to be structured in a way that the people can reflect on the portfolio. It's not collecting everything. You have to figure out what it is out of all this you want to collect, and I think the issue of getting people's permission to use that stuff is a good idea. Have them reflect and tell you here's what we've collected. You tell us what you want to show people to show what you can do. And then, use that kind of information. And my last idea is I still want to push for a journal of items that you can publish the best of items. They'll be reviewed by a panel of item writers, and so that we'll have good models out there for people to use to go over and create better items in the future. I don't know if we're improving quality of items over time or if we're not. And that's sort of the final thought. So.